everyone, and welcome back to our SwiftUI series. So last time when we were looking at game development, we built a pretty simple bullet storm game. And the fundamentals, the heart is there. But let's be honest, this doesn't really look the nicest. What if today we tackled SpriteKit and we were able to elevate our app to the next level? So we can see here I've added some background music. We also have multiple different enemy types. We have a satellite, a little rainbow star, an asteroid. They're still varying in size. We have a little background music. And when I get hit, we have a new sound that plays. We kind of get turned into some fire. Oh no, we have a background, right? And our game automatically restarts. So let's learn how we can elevate this game experience by using SpriteKit. So let's go ahead and dive on in. So really quickly, before we do hop into the project, I'm going to be posting all the assets that I'm using today in the description below. And if you want to download the previous project to follow along exactly, you can totally do that and download it and follow along. Otherwise, you can totally start from scratch when following along with this video. You'll just need to make sure that you're booting to the correct view. And if you want to sample the completed project, that is also on my GitHub pages. So let's go ahead and open up our Bullet Storm Revenge project that we were working on last time. So this is the one with the circle that we're kind of just moving around to dodge enemies, and our logic is great. But, let's be honest, it doesn't look the absolute best. So we're going to be using SpriteKit for this project. Now, because we're using SpriteKit, we are going to have to say goodbye to our previous GameView. So what I would really suggest doing is making a backup of this GameView project. So what I'm going to do is in my structure of GameView, I'm going to do underscore backup. Okay. I'm going to then Command A, Command C. I'm going to create a new empty file. We'll call it GameView underscore backup. And this is a really great idea. We're going to Command A and Command V because although we're not going to be using this scene anymore, any of the logic we created last time, if you get lost, if you want to duplicate something, right, all of it is still found within our project here. Why are we moving away from this game view? Well, we are using SpriteKit after all, and we're going to be modifying our game view quite heavily to rely on a GameKit scene instead. So SpriteKit is optimized for animations and physics, making it the perfect tool for fast-paced games like this. We'll add smooth movement, real-time physics, collision detection, and effects to make this feel like a real arcade game. So we're going to create a dedicated GameScene.swift file that'll handle all the game logic. This allows us to separate UI elements from game physics, keeping everything clean and scalable. Then we'll embed this scene inside our SwiftUI game view so it works seamlessly. So instead of handling everything in SwiftUI view, SpriteKit allows us to efficiently manage game elements in a dedicated rendering loop, leading to smoother gameplay. So we are going to take our structure of GameView and we are going to, and this is not in our backup, we're going to get rid of pretty much everything. And this is why we wanted to create that backup, right? So I'm going to delete everything all the way up to the preview. And I'm going to go ahead and rename this back to GameView. Okay, and instead of having this be a body some view, we're going to create a new variable called scene, and this is going to be a SKScene. So SKScenes do require SpriteKit, so at the top of our file, let's go ahead and import SpriteKit. We can leave our preview here as we can use this for testing, but I'll even show you in our scene how we can access the testing in that one as well. So we're going to create a scene and we'll say let scene equals game scene. Now we haven't created this yet, but this is going to be our SpriteKit scene. And we can also create a scene size. So scene.size equals, we can use a CG size here. And from here we can add a width and a height. So for our width, we're going to do something a little bit different instead of just static numbers. We're going to use the UI screen dot main dot bounds dot width. And we're going to do the exact same thing for the height. We're going to do UI screen dot main bounds dot height. So this is going to allow it to push the screen size to the boundaries of the device that we're using. And next we'll also reference the scene and we'll set a scale mode. And we're going to set this to equal dot fill. You might want to play around with this, and it might depend on the devices you're using or the backgrounds and your sprite sizes, but this will allow us to kind of fill out that screen, and we're going to then return the scene. Cool. Afterwards, now we're going to include our variable body, some view. I'm going to add a brace here, and we're going to reference our sprite view. And within the brackets, this is where we're going to have our scene that we just created above. So our scene is going to be our scene, just like that. And essentially this is going to embed a new SpriteKit based game. Wonderful. And let's also add the edges, ignore safe area, set to .all. And because we are navigating to this, what I would do is I would have our navigation bar back button hidden, and we're going to set this to be true within the parameters. Now, the only problem with this one is we might have users get like locked into our game if we don't properly give them an escape, but that's something we can always figure out later. Cool, and it does look like, I think I'm just missing one brace. I probably just deleted something improperly. So within the structure of the game view, everything should kind of be embedded, so just double check your braces. Now, we aren't going to be able to find the game scene as we have not created it, so why don't we go ahead and do that right now. So we are going to create a new empty file here, and let's go ahead and call it GameScene. Wonderful. So because we're using SpriteKit, the first thing we should be doing is importing SpriteKit. Import SpriteKit. I'm also going to import AV Foundation because I am going to be adding sound effects to our game. And I'm also going to be importing SwiftUI. So this is only necessary if you are going to be using the preview. If you wanted to just use the GameView for testing and things like that, totally up to you, but I'll show you how to add the preview a little bit later in our development here. So for the class, we're going to create a game scene, and we're going to conform this to be the SKScene. And we're also going to add a comma and add the SK physics contact delegate, as we do have things kind of colliding within our app. So there's a lot of things we can still grab from our game view backup, and we're going to be basically replicating the game, but better. So if at any point you want to even grab a lot of the logic we used in our previous file, feel free to do so. So let's go ahead and create our player. In my case, we're flying through ship. In my case, we're flying through space, so I'm going to have a spaceship. So we're going to do let player equals, and we're going to create an SK sprite node. And within the parameters, this is where we can include what the image is. And unlike with SwiftUI, where we just put image, we're actually going to do image named with camel case. And then we're going to include our string. So in my case, it's the ship. So let's go ahead and hop on over to our assets catalog. Like I said, I already have these kind of built out. We'll just go ahead and drag and drop this into our assets catalog. If you do want to download or make your own on Canva or however you want to source these sprites, you'll just need to drag and drop them into your assets catalog like I did, and make sure they're named appropriately. So in this case, the sprite for the ship is called ship. So when we're in our game scene, we're going to reference that string there. So I would check out websites also like opengameart.org, and you can even use the search function, filter by 2D if you want to use your own assets, or use mine in the description below, up to you. Cool, and in my game, I wanted to have multiple enemies kind of flying on the screen, so I'm actually going to make a variable of enemy textures. And we're doing this because I actually want the enemies that are spawning to be random. And this is going to be an array of SK textures. So we're going to have this equal an array here, and let's go ahead and add our SK texture. And just like with the image, we're going to be passing through those different images. We're also going to change this to be image named instead of just image. And this is where we're going to include the enemies. So in my case, I had star. So let's go ahead and just add a comma. We can copy and paste this a couple times. Oops, I've got the S on that. And my poor copying and pasting. I believe we also had the meteor, and then we had the satellite. So just like with our ship, I'm going to go ahead and copy and paste these into our assets catalog. If you don't, what will happen is you'll have like a white rectangle with a big red X in it, basically saying, hey, I'm trying to find the file from your assets catalog, but I can't find it within the game scene. So if you're getting that error when you are playing your game, just make sure that the names align to what the images are in your asset catalog. Cool, so this is our array of enemies for variety, right? I don't want to just have meteors. I want to kind of keep it a little bit fresh for the users. So let's go ahead and also create some variables for our background, our score label, things like that. So we'll call this one background. This is going to equal an SKSprite node. We're going to have our image named, and I believe this one was space underscore background. Just to have good habits, let's go ahead and add that to our assets catalog as well. If you're following along exactly with my tutorial, you shouldn't need to rename any of these things at all. You should be good to go. All right, and we'll also create a score label, which is going to equal an SKLabel node. And within the parameters here, we can actually add our font. So I'm going to include a font named. You can choose whatever one you want, even if you want to reference your font book here. I'm going to do a Avenir, I believe it's called, Avenir Next, and I'm going to make it bold. So you might want to just check your font book, or you can use Avenir Next. Don't use Comic Sans. I'm kidding, you can do whatever you want. We're also going to create a variable for our score, and we're just going to set this to be 0. We're going to start the user with no score, right? Wouldn't make sense if they're starting with 1,000, right? Also going to track their game over status with a boolean. So we'll set this to be false. And then we'll create a couple of variables for the score timer and the game timer, just like we did with the other game. So game timer is going to equal a timer with our question mark here. And this is actually going to control the enemy spawning and movement. Then we'll create another variable, which is our score timer. It's also going to equal a timer with a question mark, and this is going to update every second for the score. If you want to handle your score a little bit differently, feel free to do so. Oh, sorry, these shouldn't have the equals, they should have the colons. There we go. All right, next we're going to reference a override function, didMove to, and this allows us to, when we are moving to the game scene, initialize different, physics, setting up the background, different functions like that. So when the scene is first initialized, so going into our game view, we can kind of have a setup. So we're going to type out override didMove. So this is like a built-in one, and we're going to select the to view SKView. It takes care of that perfectly for us. I do love a good autofill moment. And here we're going to set the background color to equals .black. So this is just a fallback if our images fail to load, right? It's basically, for whatever reason, if my space background doesn't load, well, at least it's just like a static black background. Next, we're going to reference some functions which we haven't created yet. And the first one is going to be setup background. This is going to initialize and add the background. We'll then set up player. These are all functions we'll be making momentarily to set up the UI, so the user interface. And we will then start game. Now, it is important that you think of the sequence of how we are adding these different functions, right? We want to set up the background, add the player, add the UI, and then start the game, just so it's smooth, right? Just in case any bugs or glitches happen, everything happens in the proper order. We're not starting the game until everything's been set up. Next, we're going to be adding a physics world, if I could spell it, .contact delegate, and this is going to equal self. And essentially, this is going to enable collision detection between the sprites. Essentially, this enables collision detection between the sprites. So when the player ship hits the meteor, so that the game can end, right? Even if you want to add things like bullets, maybe in your game you can break the meteors to survive, you will need that collision detection. Later on, we're going to be adding sound here, but for now, let's just keep going with our kind of setting up our game engine. All right, we have lots of functions to create, so let's go ahead and start with the setup background. We don't need anything within the parameter, but we will add the background.size. And this is just going to equal the self.size. So this makes the background fill the entire screen. Then we'll add a background.position. And this is where we can center the background, right? You can even play around with this. In my case, I have like a nebula in the background. So if there's anything else you want to kind of shift it for, feel free to do so. And the autofill is doing a really great job. So essentially we're adding the CG point. Then we're going to grab the X and Y value. So go ahead and do the autofill. And for our X, we're going to do size width divided by 2. And for the Y, same thing, but we're going to be handling the height. So size, height, divide that value by 2. So this is basically center background. Wonderful. Let's also use the Z-axis for our background to ensure that it stays behind all other objects. So we can access that by the background.z position equals -1. So although we're not using vstack z-stacks, we can still use things like the z position in order to make sure that it's always in the background. You know, other things aren't going to kind of clip and get layered by them. Finally, we're going to add child, and from here it's going to be the background. So we use childs in SpriteKit in order to make sure that all of our sprites and assets are working properly. Okay, next we're going to do the function for setup player. So function setup player, nothing within the parameters here again. And we're going to now reference our player.position. And this is going to equal a CG point. Again, we're going to do the X and Y values. So in this case, I'm just going to be placing the player at the bottom. So I am going to be giving them a Y value. Otherwise, I want the player to start in the center. We can use our size.width divided by 2 formula from above. And then for our Y value, we're just going to set this to be 120. That should be good. We might have to play around with it, but this is just going to place us at the bottom of the screen. Next, we'll add the player size, so player.size, and here we'll once again have a CG size, and we can add our width and height. I'm going to set this to 40 by 40. If we find we're too big or too small, we can adjust this later. Okay, next we do need to handle physics. So we're going to create a circular physics body for accurate collision detection. So we're going to do our player.physics body. This is going to equal an SKPhysics body. And within the brackets, there's a couple different things you can do from. There's edge, there's polygon form. I'm keeping it basic today, so I'm going to do a circle of radius. And because we are 40 by 40, I'm going to be setting this to 20. Find that it's too big, too small, adjust that number, but just make sure that it kind of relates to the radius of the player size. Otherwise, your game might feel a little bit janky. Next, we're going to access the player physics body and set the dynamic to be false. So this is going to prevent any external forces from affecting the player. So things like gravity, if you don't include this, you'll probably start the game and your character will just like fall off the screen. So player.physics body, and we're going to use an optional here. So we're going to add a question mark, then we're going to set our .is dynamic to equal false. So this disables gravity. Or like when you're colliding with something, like it might stop it from like flying off the screen, right? Okay, we're also going to continue with our player.physics body, add our question mark here, and this time we're going to be adding a category bit mask. So this is going to be a unique identifier for collision detection, and we're going to set this one to be the number 1. All right, now we need to handle collision with any enemies. So we're going to do player.physics body, question mark, dot. Now we're going to do contact test bit mask. So this is, so we can test when things are intersecting or collision with enemies, maybe power-ups, right? And we're going to set this to be the number 2. Now that we're done with our player, let's go ahead and add that child to the scene. And we're going to add child of player. All right, what's next in our chopping block? Setting up the UI function, set up UI. I think that's how we did it. Yep. Nothing within the parameters once again. We'll add our braces, and from here this is where we're going to add things like the score label. If you have any buttons, anything else to display to the user, you should handle it here. So in our case, we're going to be setting up the score label, and then we'll add a position to it. So in this case, I want to place it at the top of the screen, but still within the center. So we can even copy and paste some code above if we want. Otherwise, it's not too bad. We're going to add our X and our Y values because it's going in the center, size.width divided by 2. And then for the Y, let's go ahead and set the size.height to be, let's try negative E. That should put it about the top of the screen. That's what I was using in my previous example, and it should be good. Then we can add the score label font size. So dot font size. Let's set this to be 24. If it's too big, too small, we can adjust it later. And we can also add the score label font color. I'm going to make mine dot white. That should contrast pretty well off of the background. Of course, feel free to update it as you'd wish. Then we're going to add our child of the score label. Next, we're going to call upon a function, and we're going to update the score label. So this is going to ensure that the score label is correctly initialized. So we're going to call update score label. It doesn't exist quite yet, but I promise we will be creating it. And then we're going to create our function for starting the game, nothing within the parameters. Let's go ahead and invalidate our timer so it stops any existing timers before starting a new one. So we'll do our game timer question mark dot invalidate, and then we'll do our score timer question mark dot invalidate as well. Okay, so we're going to be using our game timer to spawn enemies at a controlled rate to maintain performance as well as a difficulty balance. You can even, if you're finding the games too easy or if you want to have progressive difficulty, you can modify this with your own logic. So our game timer is going to equal a timer dot scheduled timer with interval. I'm going to select the second option here. Again, from our previous tutorial, you've already been through this. You probably already know how this works. So 0.3 repeats to be true. And we're going to go ahead and remove the comma and the block kind of autofill here. Then we're going to add a brace. Underscore in. Even if you want to save time, just go ahead and copy and paste it from the backup. It's a really great reason as to why we did that. So self.spawn enemy. Same thing with our self.move enemies and our self.check collision. That was funny. It's like, okay, we created the last function from this batch. Okay, now we got to create a million more. So now still within our function of starting the game, we're going to handle the score timer, which is going to equal the timer dot schedule timer with interval. Select this first one here, same as we did above, and we'll do 1.0 repeats to be true, and we don't need that block either. Brace underscore space in, and we'll create an if statement. If exclamation point self dot game over. So if the game is not over, essentially is what we're saying, the self.score is going to plus equal 1, and then we're going to self.update score. Another function we will be creating momentarily. All right, let's go ahead and hop out of the start game function here. Clean this up a little bit. And we're going to make a new function for spawning enemy. And you can save some time by copying our previous code. In this case, we are going to be adding some random enemies as well, and adding to physics. So there's a little bit that we're changing. So let's create a random x value. So we're going to say random x equals cg float dot random in, and I believe last time we did 50 to negative 50. So for the range, we'll do 50 dot size dot width height width negative 50. So this is going to randomize our spawn position along the x-axis, and we'll create a random size. So this is going to equal cg float once again dot random in, we'll do 20 to 35, but you can adjust this as needed. This is going to give random variation of the enemy size. If you want everything to be the same size, then, totally up to you. Okay, next we're going to be creating a 50% chance to spawn an enemy each cycle to avoid over the player. You can adjust this as you see fit as well. Okay, so if bool.random, and use our empty brackets there, and then add a brace. We're going to say let enemy equals SKSprite node. Then we're going to pass along the texture, which is that array of enemy textures we created above, dot random element. So that's going to pick one of the three, or how many you choose to add in the array of the enemies to spawn to the player. All right, and for their position, we'll do enemy dot position equals CG point. And for our X, our autofill here, for the X, it's going to be the random X that we created above. And for the Y, it's just going to be the size dot height. This is going to spawn our enemies at the top using our random kind of conditions that we created above. Then kind of sprinkle down, because I also want to have the enemy size be random. Have the enemy.size equals CG size. For our width and our height, let's say the width is the random. Oh, not random X, the random size we created just above here in the let statement. And for the height, that's also going to be the random size. So they're going to be a little bit funky, but they're going to be random and different. Okay, now let's create the physics body for the enemies. We're going to be creating a lot of enemy.physics bodies here. So even if you wanted to copy and paste those real quick, it might save you some time. And this is going to equal the SKPhysics body, just like we did with the player circle of radius. And because they are shifting in sizes, let's go ahead and have it adapt to the enemy size itself. So in this case, we'll do enemy.size.width. So no matter how wide the enemy is, for that particular enemy, their physics body is going to adjust for that sprite. And we're going to divide that by 2, just like with the radius of the player. When we had it to be 40 by 40, then it should be 20, right? Half of it. And like I said, we're going to be doing a lot of enemy.physics bodies here, so get used to it. In this case, the rest of these are going to be optional, so we're going to be adding the question mark. We're going to set the dot is dynamic to now equals true, right? We want them to be having some gravity, kind of falling from the sky, unlike the player that's in the static Y position. All right, let's set up the enemy.physics body category bit mask. And this one's going to be 2. Our player was the category bit mask of 1. So in this case, it's going to be 2. This is a unique identifier for the enemies. If you add power-ups, maybe those are number 3. Next, we're going to be handling the contact test bit mask. And this time it's going to equal 1. So this is going to detect collision with the player, and then the enemy.physics body. Take a shot every time I say enemy.physics body. The .collision bit mask is going to equals 0. So this is going to prevent any unintended physics bounces, right? Because we are colliding, right? We don't want these weird physics bounces, as well as if there's some objects really close to one another, then it might feel a little bit awkward. And last, for our enemy physics body, I promise here, physics body question mark dot uses precise collision detection, which is going to equal true. So this ensures that fast moving objects don't miss any collision. Finally, let's go ahead and add that child of enemy. Woohoo! We're not done yet. So we're adding a move action in this case. So let move action equals SK action this time dot move to, and we're going to include the Y duration, right? Because we're moving up and down. So the Y should be negative enemy dot size dot height. And for the duration, we can set this to whatever we want. Let's say 3.0, but essentially this is going to move the enemy downward over 3 seconds. And because we don't want the enemies to like kind of fall off the screen and stay there forever, our game would lag like crazy after a minute, we're going to have a remove action. So let remove action equals SK action once again, dot remove from parent. And then this is going to remove it when it exits the screen. We'll have our enemy dot run SK action dot sequence. and we're going to include our actions here, which will be an array. And that's going to be the move action first, comma, followed by the remove action. So this is going to run both actions in order. So it's always going to move first, and then it's going to check if it needs to be removed and then delete itself from the scene. Okay, that was pretty cool. Let's go ahead and hop out of our spawn enemy here. All right, now let's create a function, and we can use a built-in one for when we do have that contact. And it's going to be called function didBegin. So you can see here with the autofill, or maybe you can't, let me scroll that up. Called when two bodies first contact each other. We're going to use the autofill feature here, and we're going to say let first body, and this is going to equal contact dot body a dot category bitmask, a second body, which is going to look for contact as well. So let second body equals contact dot body b this time dot category bitmask. All right, and now we're going to ensure that the collision between the player and enemies trigger our game over. We only have one life, right? If you want to do like a health system, life system, yada yada yada, change the logic here. So if we're going to add some brackets here, first body equals 1 and second body equals 2, then outside these brackets, we're then going to use our or here. So those two straight lines, so shift the kind of straight line above the key here. First body equals 2 double ampersand. Oh, I forgot the double ampersand in this first one here. Equals 1, a brace here, and we're going to trigger our game over to equal true. And you know, we're going to invalidate our game timer here as well. So game timer question mark dot invalidate. Same for our score timer, right? The game is officially over at this point. The player has lost the game, and we will show game, which is another function we haven't created. Woohoo! Lots of functions to create in this one. Okay, now that our collision is properly handled, let's go ahead and now create our function for moving the enemies. So func move enemies, nothing missing the parameters, we'll add our brace. For here, we'll say for node in children, and then create an if let statement for the sprite equals node as question mark SK sprite node, comma sprite is not equal to, so we're going to do our exclamation point equal player, comma sprite does not equal to background, right? So we don't want to be moving the player and we don't want to be moving the background because we don't want the background to kind of be shifting. If you do want to have like a rotating background or something, you'll have to include that a little bit differently. All right, let's set the sprite dot position dot y, so the kind of up and down, and let's have this negative equals 30. So this is going to move enemies downward each time, sorry. And then we're going to create some logic. So if the sprite kind of falls off the screen, then we'll remove the parent as well to prevent any unnecessary memory usage by removing any off-screen enemies. So if sprite dot position dot y is less than 0, so that should be the very bottom of the screen here, then we're going to have our sprite dot remove parent, and then just like last time I misspelled position. Okay, perfect. Outside of this function for moving enemies, let's see what else we have to do. I think we need the score label. Yeah, so let's do a function for update score label. This will be a really quick one. And our brace here, and our score label dot text. All my UI kit homies will remember this one. Anyways, we're going to have our time survived, and then we'll interpolate our score. And we can add like a second, right? If you want to add like a little clock emoji or something, feel free to do so. But this is going to update the score and display this dynamically. Alrighty, then we're going to create an override function here. This is going to handle our moving of the player, and we're going to be overriding the touches moved. We can use the autofill feature here to save a bunch of time, and within our code, we're going to create a guard let statement, and this is going to be our touch, which equals touches dot, and then we're going to create our else and return statement within there. And now let's go ahead and handle a location. So let location equals touch dot location in self. Now we're going to create a clamped x, which is going to equal a min, and then immediately we're going to add a brackets with a maximum, and this is going to be for a location dot x player dot size dot width divided by 2. Outside of this bracket, we're going to add a comma, and our size dot width is going to be minus our player size dot width divided by 2 once again. So this is essentially going to ensure that the player stays within the screen boundaries. And now we're going to update our player dot position dot x. We're only moving left and right. Is going to equal that clamped. Cool, so now we should be able to touch and press on the player and kind of move it around left and right as we see fit. Outside of this function here, let's create another one. I think we needed to do our check collision and a brace here, and we're going to say for node in children, add a brace here. If node does not equal, so we're going to use our exclamation point again, player, comma, let enemy equals node as question mark sk sprite node, add our brace. The autofill is doing a pretty good job here, but we're going to create a distance here. So let distance equals, and we're going to use our sqrt like we did from last time. So our POW, it's going to be our player position dot x minus enemy dot position. You'll notice from last tutorial, this is the exact same thing. Comma 2. We're going to add those two together, and we're going to add our pow player dot position for our dot y now minus enemy dot position dot y2. Next, we're going to determine if the player is close enough to an enemy to trigger the game over. So we're going to look at that distance with an if statement. So if distance is greater than enemy dot size dot width divided by 2 plus t. Make sure you always add space when you're doing math there, otherwise it might give you some weird errors. So we're going to set our game over to equals true, our game timer question mark dot invalidate. You notice I'll add these in a lot of different spaces just to make sure we don't get any funny business. We want our score timer this time. Validate, and then our show game over will then trigger, which is another function we get to create. Hooray! It's this constant game of checkup when you're creating different functions. All right, outside of this check collision, let's scroll down. Let's make some space. We've written a ton of code today, and let's create that function for showing game over. So here we will show an explosion at player dot position. So this is going to display an explosion for effect. We can also add sound reader. We'll do that in this tutorial too. And then the player dot remove from parent. So this is going to remove the player sprite after the explosion. And then we're going to run an SK action. We're going to set a dot wait duration 2.0. And this is going to delay restart to allow players to see a game over screen. Right? If you want to add a label here that's like game over or whatever, feel free to do so. Otherwise, we're going to self restart game. Oh, you thought we were done with adding new functions? Nope. Okay, next, let's do this show explosion, restart game. I promise we're almost done. So after the function of showing game over, let's do our function of showing explosion. So show explosion in the parameters, we were doing an at here. So at position, which would be a CG point. Add a brace here. If let explosion equals SK emitter node. And we're going to be creating this in a second. So file named explosion. I'm going to wrap this in a string real quick. Explosion.sks. Brace here. Explosion.position equals that position. And we're going to add that child. So that's right to the scene of explosion. And we're going to add a run here and wait for the duration. So this is going to prevent any leftover explosion effects. So run action at SK action. Just like the second one here, which is going to be SK action dot wait, just like we did before for duration. Let's set this to be 1.0. And then we'll add a brace first. And then we'll have our explosion dot remove from parent. So when we're adding the child, it's adding this rights to the scene. When we're removing it from parent, we're removing it from the scene. All right, it's still mad at us. We have the restart game to create. Let's do that right now. Function restart game. Do anything within the parameters. For node in children. You're probably getting pro at this. Children like that. We're gonna add a brace. If node does not equal background, double ampersand. Node does not equal player. Add a brace here. Node dot remove from parent. So this is essentially going to remove any enemies, UI, but keeps the background and player. Or did I spell children wrong? Children. Yeah, there we go, children. I was like, why is it not giving me the thing? All right, and you know the deal. Still within this, so outside of the for node and children, but still within the restart game. Game over equals false. And reset our score. Score equals 0. Update score label. If we're going to use the opposite here, children dot contains player. Right here, this is going to ensure that the player is re-added after removal. Set up player and set up the UI. So we're clearing things, and we're going to basically check if the player doesn't exist. Right, we're going to reset up the player and set up the UI. Then we're going to go ahead and start the game. So we should be good to go. Let's go ahead and check our errors here. So in our did begin, oh, I forgot to include the second body here. Just like we did with before, first body and second body. We should be good to go. Otherwise we have 2 errors. Cannot find game scene in scope. That should be resolved once it kind of adds everything. So you can test this game out currently with a couple different methods. First would be to boot up our app, go to the content view, which will then load the game scene. The second is you can come to this game view here. I'll swap it over so you can see. On the game view, you can load the preview, right? Let's go ahead and load it up real quick and test our beautiful game out. All right, here we go. We can move the player. We see our little asteroids coming in. Woohoo, woohoo. Now we haven't added the explosion. We'll do that in a second. So if we go here, we kind of just disappear, right? In our game resets. If you want to add that game over text, feel free to do so. Oh, apparently I died again. Anyways, so if we want to actually see this in our game scene for while we're testing and making changes, make sure you've imported SwiftUI at the top. Come all the way down to the bottom, add a hashtag preview, add our brace, and then we're going to reference our game view here. And now we should be able to, might give you a quick error, but we should be able to load the preview in on the right side. You just have to make sure that SwiftUI has been enabled, and now we can test some things out. So in the essence of testing, let's go ahead and create our new explosion. So what we're going to do is we're going to create a new file from template. We're going to type in SpriteKit, and we want the SpriteKit particle file. And the cool thing about this one is there are some built-in ones we can use. So in this case, I'm going to choose the fire. We can go ahead, press next. We call this one explosion. Let's go ahead and create it. And you can now see it's going to take us to this kind of explosion file. So if we go back to our game scene, let's go ahead and have our player crash out. promise I'm intentionally getting hit here. Boom, you can see that this little fire does play. So we have like this little extra animation that we can use. That's one of the great things about using SpriteKit is we can add things like animations. There's some built-in ones. You can even make your own animations. It is pretty cool. We can see that our game functions just as we expect here. Sometimes in the kind of preview, there's a little bit of lag, and if you're spawning a bunch of enemies, especially in the preview, it might be causing some performance issues. But right now, because we are removing the sprites when they do fall off the screen, we've been going for 30 seconds, it's not too terrible, and our game functions as expected, which is great. There are some other things we can continue to add. In the folder, I've added some power-ups, but that is what we're going to be covering in the next episode. We're not quite done today. We do have our kind of working copy here, but to elevate this experience, why don't we go ahead and add some sound effects? So just because I don't want to lag, I'm going to go ahead and comment off our preview here, and we're going to create a new Swift file because I do plan on adding other kind of game modes to this, perhaps in the future. It's a good idea to have our game sounds be kind of hosted in a different Swift file. So we're going to call this one Sound Manager. Do you want to call it Game Sounds? It's totally up to you. But this is where we're going to be handling our game music, background, explosions, game over sound, whatever else you want to add. So we are going to be using our good friend AV Foundation. If you haven't worked at AV Foundation before, I've already done a couple videos on it, so you can go ahead and check those out. Guys, we'll go through it really quickly. Static let shared equals sound manager with our empty brackets. So this is going to be a singleton instance. We're going to create a variable background music player. It's going to conform to AV audio player. I'm going to use our question mark here, and another one for our sound effect player, which is also going to be an AV audio player question mark. We're also going to do a private initializer. And this is just completely empty with empty braces, but this is basically going to prevent multiple instances. Okay, let's handle our background music through our background music player. So function play background music. We're going to pass through a file name, which is going to be a string value, and we're going to have a loop, which is a Boolean value, and this is going to by default be true. I'm gonna add a brace here, create a guard let URL equals bundle.main.url for resource file name. All right, we're gonna call this one file name, so we're gonna be passing that through, and with the extension, I believe it's .mp3. So within a string here, we'll say mp3, then create an else statement, print error bgm not found. We can even interpolate the file name that we are looking for, mp3, and then we would return. Cool, after that brace here, we're going to create a do. I'm going to have our background music player equals try AV audio player, contents of the URL that we created above, and then we're gonna have our background music player question mark dot number of loops. It's gonna equal the loop question mark -1 0. So that's going to allow us to loop infinitely. We'll also set the background music player question mark dot volume. And this is going to equal 0.1. I want it to be pretty quiet, but you can adjust this volume if needed. And then the background music player question mark dot play. Cool. After this do brace, we're going to add a catch here as well. I'd love to be handling my errors properly. We're going to print error would not play BGM. Although I'm not going to be implementing it in my code today, let's go out of this function here. You can create a function to stop background music. And we're going to set our background music player question mark dot stop. In the future, you might also want to have options for the players to press a button and display You might want to have like a toggle or a button that they can press to disable any sound effects or background music, right? Make sure you're always giving that option to the user. And now let's create a function for play sound effect. We're going to pass through the file name of string, and basically the exact same thing. You can even copy and paste if you really want to save some time. Guard let URL equals bundle.main.url for resource with extension. So in this case, it's the file name with the extension. I believe these ones are also MP3. If you do have a different kind of file extension for the things that you've found, or you can just convert them, just make sure that you're using the proper extension within this guard let statement. Error sound effect file not found. Let's go ahead and interpolate that file name MP3 again. We would return. Then we're going to add our do sound effect player equals try AV audio player tensor. Basically the exact same thing we've been doing of sound effect player dot play. Add our catch statement. Then print error could not play sound effects. Okay, we should be good to go. Let's also go ahead and open up our assets folder if you want to download them. I think I got all of these off of the YouTube audio library. That was the one I used in the other video. Pixabay, I think that sounds right. But we're just going to go ahead and drag them over into our project here. They are all MP3s, we can see here, so we should be good to go. Now in our code, we just need to make sure that we're calling upon them. So in our game scene, let's scroll all the way on up, and in our didMove, we added our little comment for sound here. So we're going to reference our sound manager dot shared dot play background music, and with the file name, it should be called game underscore music if you're following along with mine, and this is going to loop the background music while playing. Next we'll go to our show game over, so Command F to find this a little bit easier. Show game over for our explosion here. Well, let's go ahead and add a sound manager dot shared a sound effect. This one we call game underscore over. And for our explosion, we could also add the sound here if we really wanted to. We could do sound manager dot share dot play sound effect, and this one I believe is called explosion. You can always copy and paste above there. All right, I'm going to uncomment off our preview here, and hopefully we should hear some game sound and, you know, some explosion noises too. All right, and here we go. We have our game. Let's go ahead. We're playing around. Let's get intentionally hit. Trust me. Cool, we have our game over. We have like a little explosion kind of playing. You might want to stagger those two things, but we do have our background music looping, which is great. One thing I will say from testing purposes, if we were to go to another Swift file, so because we have the preview still running, if I click on the sound manager, the sound's going to keep going. So what I would do is I would click on like the content view or somewhere else where you have a preview in order to stop the sound. Otherwise it'll go until you close the project and probably drive you insane. But we have created our game, and we can see we can access from the game view if you want to play around with it in the simulator. Simulator should be your best bet, or real physical phone. We can now play our game, and there's so many more things that you can do with this project. Next time we're going to be creating some new AI enemies. We're also going to be adding some power-ups and really polishing out this game. So I can't wait to see you in the next one. I'm having so much fun kind of creating this project. If you are following along, or if you're creating your own game, let me know what you're creating in the comments below. If there's any features you really want to see. There's so much we can really do with this project. I'm going to close this out because otherwise I'm going to go insane with the background music. And I hope you're having fun. Dream big, code bigger, and we'll see you in the next one. And if you're looking to learn more about SwiftUI, I have tons of videos on my channel for iOS development using SwiftUI. I also have my GitHub pages with all of the sample projects and templates for you to use. So if you found this helpful, like, comment, subscribe,